Data summarization. Data summarization is the application of the statistical methods on data to parameterize the data. The parameterization of the data involves several measures such as measure of central tendency, measure of dispersion, measure of symmetry and shape, measure of location, and a capsule summary of several of these measures put together called 5-number summary. Let's start with central tendency. Central tendency can be measured using several measures. One of the most common one is the mean. Mean is the sum of values divided by the number of observations in the data. It is typically used for a well-behaved data. By well-behaved we mean there are no surprising extreme values in the data set. When the data is not so well behaved, where some values affect mean more than the other, in such a situation we use median. Median is the middle value when the data is arranged in ascending or descending order. Median is stable measure of central tendency when the data contains a few extreme values. Sometimes some values or a specific value in the data occurs in disproportionate frequency, then we use mode. Mode is the value occurring with the highest frequency. Sometimes instead of median, we may still use mean by truncating the extreme values from the data. We eliminate certain percentage of values, typically 5% or 10%, from either side of the data set which is arranged in the ascending or descending order, and then calculate the mean on the middle values. Once we have estimated the central tendency, we can compute the dispersion. There are several measures of dispersion. One of the very common measure of dispersion is variance. Variance is calculated by finding the relative distance of the data from the mean, which is squared and averaged. Since the differences are squared, the scale of data and the measure of dispersion are in two different scales. To bring it back to the original scale, we find the square root of variance, which is called standard deviation. We will be using these measures throughout the course. Some other measures of dispersion include range, which is simple, the difference between the minimum and the maximum. We also calculate the range by truncating 25% of the values from the either side of the dataset and only finding the range for the middle 50% of the values, which is called as interquartile range. These measures of central tendency and dispersion work well with the data which is well behaved. In case of data which is not well behaved, we have the other measures such as symmetry and shape. A common measure of symmetry is skewness. The derivation of the formulas is beyond the scope of this course, but we can use any statistical software to compute skewness for asymmetry in the data and kurtosis for the shape of the distribution of the data. When data has no skew, the mean, median, and mode coincide. When data is negatively skewed, the mode is greater than median and median is greater than mean. When the data is positively skewed, we may have the vice versa ordering of these measures of central tendency. In case of kurtosis, we look at three types of shapes: platykurtic, which is very low degree of peakedness; mesokurtic, when the data does not have too much of deviation from the normal distribution; and leptokurtic, when the data tend to be concentrated around a certain value compared to the other values in the data. One of the commonly used capsule summary of data summarization is 5-number summary. It provides a whole range of data parameters in single snapshot, and that is visually represented using what we call as box plot, which we can see here. So we have the minimum, we have the maximum, we have the first quartile, that's the 25% of the values, we have the third quartile, we have the median, the 50th percentile, and the difference between the Q3 and Q1 called interquartile range. Besides that, mean is also included in the 5-number summary. This is a quick data summary which is often used by statisticians to make sense of the data. Oftentimes the data in the raw form is not as useful because of the dependence on the scale and the contextualization of the measures to the specific data. In that case, we standardize the data using the measure of location. There are several measures of location. The most common one is the z-score. It is the relative position of the data value from the mean in multiples of standard deviation. We will be using z-score as a basis for several of the statistical methods throughout the course. Percentile is another common measure of location. It tells us the relative position of the data values as a percentage of values between minimum and that value. For example, if somebody says it's 90 percentile, it means 90% of the values in the data set are lower than the 90th percentile value.